Today, we're talking about something pretty wild. Stars that have seemingly found the cosmic fountain of youth, and what their incredible story tells us about the ultimate fate of, well, everything.
It's one of those huge questions, isn't it? Everything we know seems to have a beginning and an end. But what if, just what if, the cosmos has an exception to that rule? So, picture this. Deep inside these ancient clusters of stars, where every single star should be old and red, astronomers see something that just shouldn't be there. Bright, hot, blue stars. They stick out like a sore thumb.
And that's the whole mystery right there. These stars look young, but they're living in these ancient stellar neighborhoods, where all their peers are billions of years old. They are completely breaking the rules of how stars are supposed to age.
And get this is not some new puzzle. For the better part of a century, scientists have been scratching their heads trying to figure out how these weirdos are even possible. Are they just cosmic accidents, or is something way more dramatic going on?
Well, for a long time, there were a couple of ideas. Maybe they're the result of some crazy head-on star collisions. Or maybe it's something a little more sinister, a slow, deliberate theft.
It turns out the leading theory is that a blue straggler is basically a stellar vampire. You have two stars born together, and as one gets old and expands, its smaller partner starts literally sucking away its hydrogen fuel. This fresh fuel pumps up the smaller star, making it burn hotter, bluer, and look way younger than it actually is.
And thanks to the absolutely incredible vision of the Hubble Space Telescope, we now have the strongest evidence yet. After looking at thousands of these stars, scientists are pretty darn sure that this mass transfer theory is the main way blue stragglers are born.
But here's where it gets even cooler. It's not that simple. It turns out that not all old star clusters are good places for a vampire star to set up shop. The environment is everything.
This whole thing revealed a fascinating little paradox. You'd think the more crowded a cluster is, the more chances for stars to interact, right? But what Hubble found was the total opposite. In those super dense clusters, all the gravitational chaos actually breaks these delicate partnerships apart before the fuel heist can even happen. It's the calmer, more spacious stellar neighborhoods where these pairs can actually survive.
It's like astronomer Enrico Vesperini said, a crowded star cluster just isn't a friendly place for these stellar partnerships. Too much action, and the stars lose their chance to stay young.
So yeah, this brilliantly shows how some stars can, in fact, cheat death, at least for a while. They can rewind their own clocks and shine brightly for millions, maybe even billions of extra years.
Which, of course, brings us right back to that huge question we started with. Blue stragglers might be able to delay the inevitable, but can anything truly last forever? To answer that, we have to zoom out. Way, way out.
Because it doesn't matter how clever a star is, the universe itself has a timeline. There's an ultimate clock ticking down for everything. And to really get our heads around it, let's start a little closer to home, with the fate of our own solar system.
In about 600 million years, the moon will have drifted too far away for us to have any more total solar eclipses. A little after 1 billion years from now, the sun gets so bright it's going to boil our oceans away. And then, around 7.6 billion years from now, our expanding sun will most likely just swallow the Earth whole. Our story ends right there.
But the universe's story? Oh, it's just getting started. The timescales from this point on are almost impossible for our brains to handle, but they chart the course for the end of everything.
1 trillion years from now, all the cosmic gas and dust needed to make new stars? It'll all be used up. The star-making factories are closed. For good. The last new stars will flicker into existence, and then the great age of starlight is over.
100 trillion years from now, the very, very last star in the entire universe, probably a tiny, tough little red dwarf, will finally burn through its last bit of fuel and die. And with that final flicker, the entire cosmos goes dark, plunged into an eternal night.
And this is when we enter what's called the degenerate era. The universe is now this silent, cold graveyard. It's just populated by the dead cores of stars, white dwarfs, neutron stars, and black holes, all just floating in the infinite dark.
Okay, now for a number that's so big it's almost silly to write down. 10 to the power of 92 years. Over this incomprehensible stretch of time, even the most massive black holes will slowly evaporate, leaking their energy back into space, particle by particle, through something called Hawking radiation, until there's absolutely nothing left of them.
Once that very last black hole is gone, the universe enters its final, ultimate states.
This is the dark era, an almost perfect vacuum, just a thin soup of stray particles expanding and cooling forever, getting closer and closer to absolute zero. This is what scientists call the heat death of the universe, a state where nothing interesting can ever happen again. No life, no complexity, just stillness.
And that, it seems, is the final answer to our question. Nothing lasts forever, not a star, not a galaxy, maybe not even the universe itself. But is that really the end of the story? Some physicists speculate that on timescales even longer than all of that, some random quantum flutter in the empty void could trigger a new Big Bang, giving birth to a whole new cosmos, a universe where nothing lasts forever, except maybe, just maybe, the chance for a new beginning,